All right, now check this one out. Let's do one more of these guys just to give you a feel. So let's say that f of, oops, yuck. Let's say that f of x equals, I don't know, let's go 1 over 1 plus x squared. Now this one's tricky, but it's really not as bad as you might think. Now, look close, all right? What I need to do is I need to find what I'll refer to as a home function, all right, that I can start with. So if I think about it and I look really close at this guy, remember, the whole thing, out of the n, as n goes from 0 to infinity, turns into a over 1 minus r, right? S equals this guy. Man, it sure looks close because I'm already kind of in this mode, right? 1 minus negative x squared. Right? So I've got an a and but what am I going to do with this squared thing? Well, let's think about this. Doesn't this smell a whole lot like 1 over 1 plus x, which we know is 1 over 1 minus negative x. A is 1, r is negative x, right? And excuse me, I know that this guy turns into the sum as n goes from 0 to infinity of, oops, that's a 1, right? Of negative 1 to the n times x to the n, because I just did kind of a two-step there, right? All right, so there's a problem though. This thing doesn't have a squared. Now students always ask me, well, Ripley, isn't this guy just this guy squared? So why can't we take this and square it? Well, there's a massive problem. Think about that. I mean, if I square this term, what I would be doing is I would be taking 1 minus x plus x squared minus x cubed plus dot, 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 and I would take that times 1 minus x plus x squared minus x cubed plus dot, 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 that's cubed, and I would multiply these together. Think about all these intermediate terms, and I would have to come up with that out to infinity. Now, theoretically, we're allowed to do that, but it's going to take you an infinite amount of time, and I don't know about you all, but I don't have an infinite amount of time. So I'm going to use a trick. Let's just look at something here. If I take the derivative of 1 over 1 plus x, let's see, that's the same thing as the derivative of 1 plus x to the negative 1, which turns into negative 1 over 1 plus x squared. Hey, wait a sec. Wow, wait, whoa, that's nice. We're close. I got a negative. So that's okay. We'll just deal with that. Okay? We're not afraid. So I know that 1 over 1 plus x squared is equal to negative 1 over 1 plus x squared. Now, this guy right here is the derivative of 1 over 1 plus x, which we've already determined. I got too much writing going on here. Is this guy. Now, what do your instincts say to do? What do your instincts say to do? Well, if I could take the integral, remember this guy back here? I could take the integral of a sum. Why can't I take the derivative of the sum? Remember, the derivative of the sum is the sum of the derivative. So it's really, really simple to do. I know that the derivative, if I just do a quick little algebraic extension, if I know that the derivative, d of x, of negative 1 over 1 plus x, right? That's this negative right here turned into this negative, because I want to be able to account for that negative, see how that works, is equal to 1 over 1 plus x squared. True? So here we go. That implies that the derivative, d of dx, of the negative times the sum as n goes from 0 to infinity of negative 1 to the n times x to the n. We are taking the derivative of a sum. Now, I'm going to pop over here because I'm going to run it. I may forget what I just did. Let's see, d over dx of negative sum as n goes from 0 to infinity of negative 1 to the n, and then what did we say? X to the n, wasn't it? X to the n? I think that's what it was. Let's double check. All right, let's double check. Yeah, beautiful. And I'm golden. Now, this equals, we know that since this guy right here is equal to negative 1 over 1 plus x squared, right? Wait, I'm sorry. Negative 1 over 1 plus x, I know that this thing's derivative, whatever it's going to be, is going to equal a positive 1 over 1 plus x squared. That's so helpful. It's so useful. Now, all I got to do is figure out what this thing turns into. Well, this is going to be the derivative of, wait, I just lied, you guys. I'm sorry. This little term in here is what I'm talking about. Let's make sure that we understand. All right? So let me erase this and get out of my own way. This is going to turn in, I'm going to do a little bit of algebra here because it's going to make for an easier derivative. d over dx, now remember, think of this as a negative 1 and it distributes across. So this becomes the sum as n goes from 0 to infinity of negative 1 to the n plus 1 times x to the n. And this is equal to what? Well, the derivative of a sum is the sum of the derivatives, right? So I could just go n equals 0 to infinity of d over dx of negative 1 to the n plus 1 times x to the n. Well, again, just like I said before, notice I'm taking the derivative with respect to x. If it doesn't have an x in it, like say this guy, then I don't worry about it. So this becomes the sum as n goes from 0 to infinity of what? Well, the negative 1 is a constant, n plus 1. There's no x involved with this, and this becomes n x to the n minus 1, which is equal to 1 over 1 plus x squared. Isn't that wild? That's crazy. Let's just a quick little recap because I know that that's tricky. So notice what I did. I noticed that this term right here looked remotely close to the derivative of this term right here, which was easy. Notice this is a equals 1, r equals negative x. That's all I came up with, and this is what its infinite series looks like. True? We've played around with these enough. Hopefully at this point, I know it's tricky. Bear with me. So I played around. I said, okay, the derivative of this is equal to this. Well, I don't want the derivative of, I don't want this. I want this. So I threw a negative on. Threw a negative on this, which we know turns into this. So I threw a negative on the series. Well, and then I did a little bit of algebra. Got a little confusing in here. I apologize if that's confusing at all. Distributed the negative 1 through. I ended up with this. The derivative of the sum is the sum of the derivatives. And I ended up with this. Now, what's the radius? Well, the radius of the derivative is the same as the radius of the original function from whence we came, so to speak. And r in this case is negative x. So I know that absolute value of negative x is less than 1, which implies that x is between negative 1, implies that x is between negative 1 and 1. I end up with exactly the same radius in this case. I know that absolute x is less than 1, which implies that x is between negative 1 and 1. Now, if I need to check my endpoints, I can. It's pretty easy to see what happens here if I do check my endpoints. It's not so bad. But I'll leave that to you guys now that we've got some practice with that in terms of the ratio test. All right? So, hope you enjoyed. Hope that that explained it to you. We're going to do a bunch of these in class. Of course, you can pick my brain as much as you need to. Thank you for your time and your attention. We're almost done, you guys. We've only got a couple more sections to do, and then we're finished. Have a great day. Bye-bye.